Are you preparing for a role as a cloud architect, cloud administrator, cloud engineer, DevOps engineer, AWS solution architect, or data engineer? In many cloud related interviews, they can ask about your understanding of how to handle traffic distribution and scaling, which is crucial for any production environment. And that's where load balancers come into play. Just like a busy coffee shop needing more employees to handle the crowd, load balancers help distributed traffic across multiple servers to ensure your application performs optimally. And in this video, we will break down AWS load balancers, focusing on their types: application load balancers, network load balancers, and gateway load balancer. We'll also explain how they handle traffic, improve performance, and ensure high availability. We'll look at real-world scenarios like how companies use these load balancers to route traffic efficiently and securely. And also, if you're looking to start your AWS career but don't know where to begin, join our free AWS job-oriented masterclass. In this class, our experts will share the proven 3-step plan that has helped many people land their dream cloud jobs. So click the link below to register. Also, today's video is a part of our AWS job-oriented program. So let's get started.
So now, load balancer. Yes, there is a startup, the coffee shop. Someone is coming, one customer is coming, 2 customers are coming, and there is only 1 employee who is handling the coffee shop. So yes, it can easily be managed. What if 60 customers are coming and 1 employee is managing? No, in that case, we have to hire more employees. And if more employees, let's say 7 employees are there, and we have divided the task as well. In that case, 60 customers are handled by only 1 out of 6. Doesn't make sense. So in that case, we use load balancer to balance the load. We will not overload one person. So we will divide the load. So load balancer, in technical terms, in technical aspects, distribute the load. Let's say there is only 1 server who is handling all the load coming. So what we do is we have multiple servers launched and we are using load balancer, which will automatically distribute the load if the load is high, right? So yes, it will improve the performance of an application rather than overloading one server. Once the load is distributed, the task will be completed easily without any issues, right? Without any interruptions. So there it works. Now, if we talk about load balancer in AWS, then we have ELB service, which will help you. So first of all, the client applications making the request, sending the request, and this request is distributed across multiple servers as these are available. The load is balanced. It provides you high availability, incorporate the security feature, performance health check also means either your health of your servers is fine or not. Is it working fine? Is there any issue? So it will be checked. If health is not good, it will reject your request, right? And it automatically distribute the traffic. Now, health check, as we talked about. So here, health checks are crucial for load balancers. It enables the load balancer to know if the instances forward the traffic to are available to reply to the request. Yes, it is available or not. So health is monitored. It is done on the port or route. So here /health is common. So you can see here, this is the endpoint. We're checking the health of the server, making the request to this server, and after balancing the load. If everything is fine, it will show you 200 is for okay, or it can show you 404 error as well. It can show you 5x errors as well if the instance is unhealthy. That's how it is, right? Depends. So after checking the health, yes, when you make the request, it shows you that parallel. If health is not good, it will not display your web page, right? That's how it is. What are the types of load balancers? So let's discuss that. So these are the types and when you can use which type of load balancer. Simple. So as we have application load balancer first, network load balancer, right? And you have gateway load balancer. So 3 types of load balancer we have. First is application load balancer. So when we talk about application load balancer, so you have HTTP and it supports HTTPS protocols. It works at OSI layer number 7, which is your application layer. And it is URL based. It gives you the features like URL based routing, host based routing, WebSocket support, and SSL termination. For example, let's say there is a web application with multiple services. Multiple services, for example, let's say slash API, or let's say slash admin, or let's say slash login. So different services are there behind the same domain. Let's say Amazon.com routes their traffic to checkout to one microservice and direct their traffic to search to another using ALB. That can be done simply, right? So for that, for such type of services or applications, you use application load balancer. Now, next we have is network load balancer. Network load balancer, by the name suggests. Specifically, yes, it support these protocols and it works at OSI layer number 4, which is your transport layer. It provides you very high performance static IP, low latency, and it can handle millions of requests. For example, let's say there is a trading application or gaming application where latency matters. Let's say stock trading company like a Goldman Sachs, they uses NLB to ensure millisecond level latency, right? So where it is required, yes, you can go choose this load balancer. Again, depends upon the use case. Now, third is gateway load balancer, the newest one. And yes, it is used by most enterprises. Gateway, by the name suggests, it provides you the gate, means more security. So it support this IP, works at layer number 3, network layer. It integrates with third-party virtual appliances. What are those virtual appliances? Firewalls, Palo Alto, right? Or any IDS or IPS, means intrusion detection system or intrusion prevention system. And it centralizes the inspection. For example, like you want all the traffic to pass through the firewall, like Palo Alto or Fortinet before reaching to EC2 instances, you configure gateway load balancer. And yes, like in banking or healthcare firm, you can use your gateway load balancer to route all the patient record to access through a security appliance. And there you go for this type of load balancer. So you can choose any of these, right, based upon your requirements, right? So if you want to choose any of these, you go with the console. And yes, of course, this is specifically for your servers. So you have to go with that. And you can see here load balancing, right? So you click upon load balancers and you create your load balancer. So you click upon create, it gives you all three, right? So classic load balancer is not available, which is for previous generation. So all classic load balancer capabilities are given in application, so it is not needed. If you want to create any of these, you select that, you configure, and how it works. The workflow is also given, right? You provide the load balancer name. It will, where you are creating this load balancer. Network mapping is required. So it will distribute the load across all these availability zone. Yes, you can choose the subnets. Listener target group, it should be there. You will route the traffic to the target group where the targets are added. Targets are your instances, right? And then you create your load balancer, right? That's how it is. So you can choose any type of the load balancer as per the use case. I hope it is clear to everyone, right? So I hope the types of load balancers and use cases are clear, right? So lab is also given. It is done by few of you. So I appreciate if you try the labs as well. Is there any architectural diagram to display the same? Yeah, the same diagram which I have shown you here is the diagram you can see for load balancer where it is. You can see the load balancer here. Okay, it is highlighted here, right? So this is the architectural diagram in AWS Cloud. You can consider. Okay, got it? Yes. So here it sits. With it is outside, like within your VPC, but outside. So if you have noticed while configuring your load balancer, so where you are directing your traffic, there you are selecting your subnets, right? Where you want to send your traffic. And these are your, you can see the targets, the targets group you have created where you have added the instances as the target where your load will be balanced, right? So you can consider any type of load balancer, the architecture is same. Got it? Bhushan. I hope it is clear. Yes, you're welcome. Thank you. Now, let me is so you can see the components. Yes, that matters. You have created the load balancer. So listener listens the request, right? And the listener, after listening the request, let's say you want to allow the listener port number 80, right? Now it will send the request to the target group where your targets are registered. And what are these targets? These targets are your instances. That's how it is. So these are the main components of your load balancer. When you configure it, it is needed. All these components are needed. That's how it is. Now, next we have is the common features. When we talk about the common features, so next we have application load balancer and we have a network load balancer, we have gateway load balancer and the comparison. So let's discuss this comparison now. So here we are comparing the health checks first, the health check for application load balancer, and you can see the health check for your uh, network load balancer and all. So first, the health check support health check to monitor the health of your target resources and all support. So if a web server crashes, the ELB automatically stops sending traffic to it. That's how it is. So all supports. Cloud Watch Metrics also supports. For monitoring matrices, request count, latency, and errors, you set up the alerts when the response times increases for any particular shopping site. Yes, there it works. That's how it is. So that is needed. Now, next we have is the request offloading and logging. So after CloudWatch Matrix, we have logging. So all supports your logging again, all type of load balancer for auditing and debugging. Use it to trace suspicious IPs hitting your login endpoint repeatedly. And SSL offloading, here all can manage SSL termination, offloading from backend, but gateway doesn't. So for example, when we are using SSL offloading, offload the CPU intensive SSL disk decryption from EC2 to ELB. Yes, there it works. Connection draining works. Now we can say that is deregistration delay. So all can wait before closing the connections to deregistering the instances. That's how it is. So let's ongoing user session complete before terminating a server. There it works. Preserving source IPs for all support this for backend visibility. It is required for geolocation logic or IP-based throttling. Then we have static IPs. So static IP, ALB not natively supported, but can use Elastic IP via NLB integration. NLB and your gateway load balancer, yes, they support assigning Elastic IP addresses, right? When whenever you need all these Elastic IPs are needed, whenever firewall or DNS rules are needed, fixed IP, for example, third-party APIs, in that case, it is needed. That's how it is. Next we have is Lambda function as a target. So in that case, only application load balancer support this. Like you can use Lambda for serverless processing of lightweight requests. For example, if you are submitting the form, so there it works. You can redirect the request. Means only load balancer supports URL redirects, like redirecting your request from HTTP to HTTPS or home to, let's say, example to dashboard, right? That's how it is. Now, last is your fixed response actions. This one. So only ALB supports static responses for certain conditions. For example, like it shows maintenance page or error code with 403, 402 without hitting the backend. So this is the example of fixing response actions, and there we go. Okay. So I got one query. I will explain that. Allow me 1 minute. Select the arrow. Yes, I hope all the comparison is clear, rest, right? Clear to everyone? All comparison is clear. When we talk about SSL offloading, so first you need to understand what actually it is. If we talk about SSL offloading, it means your load balancer is handling, I hope Bhushan, you know about SSL, TLS encryption, decryption, right? So it handles both of your HTTPS traffic instead of your instances. Why? It is used. Encryption and decryption require CPU power, right? So that power is on your instances. If it is done on EC2 instance, it increases the load and slows down the response. So offloading it to ELB reduces your CPU usage on your EC2, improve the performance, and centralizes the SSL certificate management as well. Let me give you one example which will help you for better understanding. For example, let's say Amazon.com using HTTPS. Instead of configuring SSL on each backend EC2 instance, you upload the SSL certificate to load balancer, application load balancer. Now, all HTTPS traffic is decrypted to the ALB, and then it forward unencrypted the HTTP traffic to EC2 instance in private subnet. That's how it is. I hope it is clear, Bhushan, and to others as well. SSL offloading. Yes. Thank you. Fixed response action also. Yes, let me explain it again. Yes, as I have already mentioned, fixed response action by the name suggests, yes, that is actually a fixed response for, let's say, when you are using ALB, as it is only provided by ALB, it allows you to send custom HTTP response. For example, status quo. Bhavna, I hope have you ever used or clicked any web page and it is showing you 404 error, right? Any error code message, right? I hope you face that, right? So yes, this is, you have sent a custom HTTP response, and yes, it will provide you that particular response rather than showing you the actual page without forwarding the request to a target. Means target is your instance. Now, let's how it is working when we are talking about fixed response. When the request matches a rule condition, but of course, in backend, it is configured like a specific path or host name. If ALB immediately return a predefined HTTP response, let's say status code. If everything is okay, it shows you 200. Okay. 403, 404, or 50 for server errors, right? Message body you have specified, custom HTML or plain text. Headers you have added, custom headers, right? So based upon that, it is performing that means providing you fixed response. That fixed response, like your status code messages, you manage, let's say in real time, if you are managing any website where let's say you have slash maintenance. This is the page. Okay, you're trying to access. The page should not hit the backend, but it shows you site under maintenance message. And I hope you have faced that also sometimes. So here you have configured your ALB in that case. Okay. And if URL path is maintenance, then it will return you HTTP 503 with the message, we will back soon, right? So this is configured in backend and no traffic goes to EC2. ALB is handling the full response here. So this is what we call as fixed response action. I hope you got it, right? Perfectly fine. Now, okay, one more query from Bhushan. You're asking for customized error response. Yes, the same manner when in from backend you are specifying any custom responses. So it allow you to override the default error pages. Default error pages, Bhushan, like we have. I hope. Let me erase it first. Allow me 1 minute, then I'll write on the page. Yes. So I hope you know the error codes. Let's say 4xx, any or 5xx errors. So these are the errors which the client sees and replace them with on HTML or JSON message, right? So these are your customized error responses, right? When a target, what is your target? The target, of course, your EC2 fails or return an error like let's say 404 or 503 or 403. Okay, it can be anything. Now you detect the error. Once the error is detected, it will return a custom message such as a branded HTML page. It can show you, it shows you sometimes JSON, right? And when I have shown you static website hosting, I was not able to access the web page, right? It was showing me access denied and it was showing me a script, HTML script there. So that was customized, right? Or any plain text message, it is visible there rather than showing this or this default errors, right? That is your custom error response. Okay, I hope it is clear. Thank you so much. Perfect. Now, next we have is, I hope it is clear to everyone. All the topics we have covered here are clear, right? Now, yes, we have discussed all types of load balancers in detailed manner, and I hope all, yes, Satish, definitely. So this is the last slide we have. Okay. So the features, yes, key benefits of your load balancer we have is that support registering, target IP, routing, health check, better performance, and route your request to multiple applications hosted in single EC2. As we have discussed in detailed manner, I hope you are able to understand why we have all these benefits, right? So let me show you one load balancer creation so that at least it will be more clear. The use case, the features, everything we have discussed in detailed manner. So let me show you creation also. So I'm going to create an LB. Just create. How it works, that we already have discussed. Client makes a request to your application. Load balancer receives the request either directly or through endpoint. Then listeners listen your request and pass your request accordingly. And healthy targets in one or more targets group receives that request and yes, provide you the output accordingly. So just name your load balancer. My NLB load balancer is the name. Now, next is scheme. Scheme can't be changed after the load balancer is created. So either you need internet facing, which serves internet facing traffic, has public IP, DNS name resolved to public IP, internal if you need a private IP. So let's go with internet facing. Now, yes, let me choose IPv4, which is default selected. Dual stack means if you have both type of addresses, it includes both. Now, VPC, which is, yes, which is needed, required, of course, when where your target, where your request goes, will be distributed, of course, in the targets. The targets are your servers. Where are your servers? In your VPC, in your subnets. So you are directing your request across multi-AZ, right? So we have selected 2 AZ here rather than more. Now you can select your security. Of course, you have to apply firewall rules to secure your traffic, which is coming to your server. So we have selected the security group as per the VPC, default VPC, default security group, and default subnets. Now, listeners and routing. The protocol, you can choose any, depends upon your use case. Is suitable for web browsing. So let's go for this. Target group should be there where you are going to add your targets, your instances. So yes, I have created already a target group NLV, which you can select it from here. Now, the tags are optional. I would like not to give any tags just to identify the categorize your, you can say the load balancer. So it's okay. Like it is a production web server or any other. So you can choose the tags. Now, very interesting feature, which is the part of your advanced course, advanced architecting on AWS. But if it is coming here, let me explain it. Now, Global Accelerator is a service which gives you good performance. For example, we are balancing the load, sending the request. So it accelerates the speed, it improves the performance, and yes, availability as well. So if you want to apply your global load balancing across multiple regions, then global accelerator can be used. If you want to create the accelerator, you can provide the name, right? So it will provide you some static IPs from the pool of addresses automatically, and yes, it will direct your request. So it is not needed here. Now, review what we have selected, right? We have selected basic configuration, security group, network mapping, listener, and routing. And if you remember, we talked about it. Now, next is create the load balancer now. So yes, successfully created. These are the listeners. This is the network mapping where we have selected VPC and AZ's subnets. Resource map, it shows you. You can see here, you're just directing your traffic. The listeners listen to your request, pass it to the target group where your targets are added. So no targets added as of now, right? So you have to add the targets. You have to register your targets. Security, we have applied as security group to our instances. Monitoring, of course, by your CloudWatch. Integrations are possible. Yes. Can you see Global Accelerator, config, CloudWatch, traffic monitoring, endpoint service? All these services can be integrated, right? So you can see it is optimizing availability, performance availability. Here it provides you monitoring and compliance. And CloudWatch internet monitoring can be done using CloudWatch. Traffic monitoring also can be done. And yes, for private connectivity, you have endpoints. That's how it is. So I hope all these features of load balancers are clear, and configuration also. Attributes, yes, we haven't enabled it. It is not needed. Capacity also not needed. Tags we haven't applied, right? So I hope the main components we already have discussed, and I hope it is very clear to everyone, right? How we can configure the load balancer, right? Now, where you can register your targets, go to the target group. And we have selected which target group I have selected. This one or this one? Which one? You remember? I think I have selected this one. So here you can see, yes, perfectly fine. Thank you, Hamid. Just testing that you are watching or not. It's great that you are watching it. Perfectly fine. So next, yes, you can see here targets. So you can register your targets. So it shows you if there is no targets added. So it is showing you 0. So first you add the targets. Oh, no instances. Why? Because I haven't enabled. So let me open it to a new tab and let me at least enable one instance. Okay. Just to show you. Let me start this so that it will be visible. So once your instance is ready, so you can see it is in running state and you can include as pending below. And yes, registered here. Okay, register pending targets. So once it is registered, it will be available and you can see it is unused. So currently it is not in use. No override. So you can see, I hope the complete flow is clear from configuration of load balancer to the targets, right? I hope everything is clear, right? Clear to everyone how to create the load balancer and how to how to configure your, how to register your targets in the target group, right? Clear to everyone? So let me answer your questions. First, I got one question for unused. After registering for it, should be not an unused. Means, yes, let me explain you why and why not. Let's say if your target EC2 instance is registered correctly, it should not show as unused. Absolutely perfect. Right. So can you see here still it is unused? Why? Because it is not in running state, right? So you register your instance Linux server on port 80, but it still shows unused in target group of your NLB. So you can check your load balancer, right? It is not associated, right? So you go to your NLB configuration, check your instance ID, right? You need to check your health check. For example, TCP port should be 80, same as your target. Go to security group, port 80 should be allowed. Check your knuckles. Okay, so that's why it is showing you. So this can be your solution in that case. Now, next is the uh, IP and the port always, wait. Yes, exactly. Correct. Now, IP is the IP and the port always a fixed one. You're asking this for this instance, right? When while creating your load balancer, right? For instance, type target group. Not IP is not manually set. IP is resolved internally by AWS using private IP of registered instance. So it can be changed, Swapna, if the instance is stopped or start again. Okay. If you are using Elastic IP, then it will be fixed. That's how it is. Got it? So, and port, if you're asking, you define it during registration. I hope you remember when I have configured the load balancer, it has asked me the target group. So parallelly that time, it was showing me the listener rules also. So there I have selected TCP port 80, if you remember. Right. So you can't change the port unless you deregister. So to change the port, you have to deregister it. Okay, this is the answer. I hope it is clear. Listener for the load balancer is similar to what we have in Oracle database. Can we configure the additional port like we do in Oracle database? And for example, we have this one. Yes, of course, we can. You can attach multiple listeners to a single load balancer, each with different ports. Suppose you are running Oracle DB on EC2 and you want your 1521 as per your example. Let's say if you are using 14584 for backup or read replica. So listener 1, you can set it to port 1521 and forward to target group A for primary DB. Listener 2, you can configure the forward it to target group B for backup DB or your disaster recovery. So you can configure each listener under the listener tab of your load balancer, define the port, protocol, and the target group. Yes, it can be done. Got it, Renault? I hope it is clear. Okay, great. Yes, Bhushan. Can you see? I have created this load balancer in this region, right? I have selected a region already. It is not global. Can you see on the top? And Virginia. So yes, it is region specific. If it is showing you global, it is not region specific. Now, I can see one question from Jolly as well. What need to be done to undo to avoid the cost? Yes, you can delete the load balancer. What I'm going to do just after showing you this demonstration. Select your load balancer, go to action and delete it. And delete your target groups. Delete all target groups attached, right? So it will not cost you, but yes, cleanup is your best practice, which you can follow. Other than that, delete your volumes, also save your cost. Release Elastic IP. If allocated, go to Elastic IP, select and release. Elastic IP is charged if it is not attached. For example, Elastic IP is created and it is not attached, it is not associated, it will charge you. If it is associated, it will not charge you when your instance is in running state. Okay, so you have to take care of these things. Okay, Jolie? Got it? Thank you. Yes, yes, correct. That's how it is. So now, do you want to associate it with new load balancer or existing? You can do that, right? NLB, it is talking about. So NLB is your target group. So now, let me delete this. Oh, I don't need to delete this. Let me deregister the target. So deregistering target also helps you to save your cost. Simple. So it is draining. Now I will delete the load balancer. Cost, okay, one more question. How the cost is calculated? To load balancer. Load balancer creation. Yes, depends. For example, let's say if you are running your instances, okay, so you will be billed per hour for each load balancer when you are running. So it is not that much, around $0.0225 per hour. Varies by the region. It is not same for all regions. Okay. So if no traffic is coming, in that case also, it charges you this much of cost for per hour. Other than that, data processing charges are always there. Per GB charges are there. Per GB around, let's say, 0.0008 per GB process charges are there for ALB. And per GB charges for your NLB for static IP if you have used, and per hour charges for your gateway load balancer as well. Okay, so yes, cost is there. Depends upon request as well as the load balancer creation. So that's why I have deleted, of course.
So that wraps up our in-depth look at AWS Load Balancers. Now you understand their working types and how they help distribute traffic, provide high availability, and improve your application's performance. To take your cloud career to the next level, make sure to join our free AWS job-oriented masterclass that I mentioned earlier. You can register through the link given in the description below. And also, if you like this video, make sure that you subscribe to our channel and also make sure that you check out this video next.